Cool, is that going? Awesome. All right, we're just going to go over the do now answers. I just want to make sure you guys understand what you're doing. It's a lot of work, unfortunately, for an achieved point, which is really irritating. First thing that I would do whenever I'm tackling this question is make that little slashy kind of list so you know the order that you're putting things in. I don't know what else to call it. The way we do that, you start with the first shell level. Remember, the first shell level only has the S shell. Second shell has the S and the P, so it's building itself up. Remember, it's 2 and then it's 6. Third shell is now going into the D shell, which is 10. And then the fourth shell, we're picking up the last one. And then I like to add a couple extras just because I don't know how big we're going to go. Usually it's not too large. 5D6, 5D10. So I normally go up to 6. Where?
Right here.
Thank you. What is it? 14. Thank you. Good catch. It's a little early in the morning. All right, cool. Are we good? So that is hopefully something semi-easy to memorize because it is just like a pattern and a sequence. You need it, obviously, like I said, to fill in those little shells correctly. Remember when we were filling in the shells? Start with that one, then 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 that one, and then that one, if it is going that big, but it won't go that big. Cool? All right. Let us look at those questions I gave you. So the first one we had to do work on was sulfur, which is 16. So sulfur has the atomic number of 16. So I'm doing this to 16. So that's 2. If you want, you can do a little tally on the bottom just to keep track of the number. So we're doing 1s2, next one 2s2, that's another 2. Then that one 2p6, 1, 2, 3, 4, 5, 6. We're at 10, and then we're going here, 3s2, that's another 2, and then I need, how many more? 4 more, because I'm at 12. So then I go that one, back to 3p, but I'm not filling that shell because we only need 4 there. So what you got? All right. The other thing you can do is you can look at the periodic table and see where sulfur is. So if we look at the notes from the other day, let's pull them up. There is a shorthand you guys can write. I don't know if it's necessarily any easier. It's up to you if you want to do it. The main thing in this case is just finding the latest, sorry, I would say the most recent is probably the best word I can use. Not the closest noble gas. Where are my notes? There we go. Hopefully I have it scanned. There you go. See? So we're looking at this bit here, keeping in mind. Something to keep in mind then is sulfur is, where are you? You're right here, the one before chlorine. We're not using the closest one. We're using the one that is most recent, filling-wise. So that would be, oh, that doesn't have all the electrons. Let me see back to my notes. Here. Let's put it on the screen so you guys know what I'm talking about. So sulfur is over here. Argon's technically the closest, but we need to go by what is in the order based on filling. So the closest noble gas you have was neon. So if you want, you can shorthand this by writing neon, Ne. Now, neon has the atomic number of, I want to say 10. 2, 3, 4, 5, 6, 8, 9, 10. It has the atomic number of 10. So what I can do then is this here adds up to 10. So I can just shorthand the rest of it. So that's also an acceptable answer if you want to do that. Again, also looking at our notes, you see how this here is filling that P2, and that's where neon would be. And so that's why you're doing the 3s still and then the 3p still. Cool. All right, next one I had was, let's go back here, cobalt. Just grab a new color. Cobalt has the atomic number of 27, so a little bit bigger here. I know. All right, so we are trying to get up to 27. We know we have at least 10. This is 10. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is already what I've accounted for. Then we go to the 3s. It's another 2. 1, 2. 3p6. That is another, what is that? 6. 1, 2, 3, 4, 5, 6. And then we're going to 4s2. 1, 2. And then I need still 27. So we are going back up here to the 3D. In this case, 3D is only going to have 10. Sorry, not 10, 7. 1, 2, 3, 4, 5, 6, 7. Now we're done. Cool? Again, if we want to shorthand it, we can look to see where cobalt is on the periodic table. It is over here, so you're going to be filling to argon instead. So you do AR, which would be 18.
Do we have to?
No. These are both correct options. I just want to point it out because sometimes in the marking schedule, they do the shorthand version as well. So argon's over here. No, down here, isn't it? 1, 2, 3, 4. 1, 2, 3, 4. Yeah. So you will basically have the 3p there, and then you're going to do these last two. Sorry. That's for argon. This is the last two.
Can you explain how you got argon?
So when I'm looking at the periodic table, here's where cobalt is. So I need to go to its most recent noble gas, which is argon. So I go backwards. It's not the closest, it's the most recent when you're coming filling it, because we can't go from here and then do subtractions.
What do you mean?
So most recent, so like if I'm going to fill these in order, the last noble gas that I touched was argon. We can't go forward and then do subtraction because that's not how the shorthand works. We good? All right, just be mindful, because this is now a transition metal, if we are doing any cobalt ions, you are not taking them off of the 3D, you're taking them off the 4s, because that's the furthest shell. So just be careful of that, and you'll see that with chromium. So what we're doing next. All right, chromium has the atomic number of 24, but we are dealing with a charged ion, which is positive 3, so it has lost 3 electrons. Now, personally, the way I do it, do you want me to show you the wrong way first? Just so you know what wrong looks like. All right, let's say you were doing chromium 3+. You know it has the atomic number of, what did I say, 24. So if I have a positive 3, that means I've lost 3 electrons, so really you're dealing with 21. Now, if we filled this the way that we're used to with this slashy kind of thing, we would have done 1s2, 2s2, 2p6, that gets me to 10. And then we would do 3s2, 1, 2, and then we would go to 3p, which is another 6, 1, 2, 3, 4, 5, 6. And then we would go to 4s2, 1, 2, and then we would go back 3d, 1. So that's what you would do if you were doing the fill in the swipey. Yeah? This is incorrect. Because what should happen is when we are taking those 3 electrons off, we should be taking them off of the s. Okay? So that's why this one's wrong. The other thing to keep in mind is that cobalt has an exception to the rule. So it has a half-filled 4s shell because it can have a half-filled d shell. So just keep that in mind. So what I would personally do is I would fill in the element first and then take the electrons off to make sure I'm taking them off properly. So this should be, and then I think it's 3d5, and that should add up to 24. Yes, it does. All right? So remember, cobalt's an exception to the rule. If I'm taking 3 electrons off, I take it off the 4s first, and then I take the other 2 off of the 3d. So that would bring it to 3. 1, 2, 3. So this is the correct answer. What?
3D1.
I took 1 off here. There's 3 electrons being lost. 1, 2, 3. Are we okay?
So you've completely removed the 4.
I completely moved 4. Because you take it from the furthest out first. So the reason why I'm pointing this out, and the reason why I selected this, is that, actually, I think this is actually a past exam question. They often ask for you guys to do the exceptions to the rules, and they often ask to do transition ions, because this is 2 spots that they can make sure that they can catch you. Say you don't know the rules. Again, it's a lot of work for an achieved. If you don't get it, don't stress. All right, it's useful for some of what we're talking about today, but again, not the end of the world. What was something else I wanted to add? I'm trying to remember now. Oh yeah, if we wanted to shorthand this, you would have, again, argon, and then you would have 3d3. Sometimes when it comes to these transition ions, So yeah, sometimes when it comes to these transition ions, you'll just have the noble gas in brackets, because when you're forming a lot of ions, say for example, if I was forming, so let's say I had sodium, and sodium lost its 1 electron, and I was doing the electron arrangement for it, it's now technically neon, because it's lost that 1 electron. And so if you just wrote on your answer brackets Ne, you'd be done. So the bracket version, no. I'm just showing it to you because it often comes up in the marking schedule, and if you do get it, it's a good shorthand. But it's not a requirement. Cool. If that confuses you, then don't worry about it. All right, moving on. You guys good? Questions, concerns, comments? It's a lot of work for an achieved. I'm very sorry. All right, can I move it? So pause recording.